Hello there, welcome to the wonderful world of radio frequency and electronics engineering. On the bench for repair today is a Kenwood TM441E UHF radio transceiver. This particular transceiver has a fault label underneath it, which, if I can barely read the writing, it says defective. It says display not always right, it says. So, but I've noticed in looking at this display, when I'm trying to move ahead while it's, you can see the digits are going a bit funny on the 2 there, on the frequency, and the 0 just there, and then it sort of comes back, and the backlight as well can diminish as well as you're pulling on it, and then it comes back. So, but first of all, I think before I do anything, we'll just check that it transmits and receives. Obviously this control works there, so 430 megahertz dead, I think. But yeah, as I was manipulating the head, then pulling it about, it certainly showed a strange frequency. Anyway, so we'll just give it a quick test on the ROHDE SCHWARZ radio test set first before we go into it. These are known for issues with the connector that goes between the control head and the radio body having dry joints or broken solder connections. So that might be the reason why this display is going a bit corrupt, because it sorts itself out when we turn the frequency control. Okay, so we'll just do a receiver test first and see what we can do. Sounds like the volume control's got a few dead spots in it, so we might need to spray some switch cleaner in that and try and get that going a bit better. So sensitivity is good, talking about 0.17 of a microvolt, which in dBm terms is neg 122 dBm, so there ain't anything wrong with that. Okay, so we'll go on to TX test, and we'll set an RF frequency up to 430 megahertz, and so we can measure the frequency error as well as the modulation and RF power, which will be read there on the display. So we'll just zoom in so we can see that a bit better on the display. Right, here we go. Radio test 1 2 3 4 5 5 4 3 2 1 1 2 1 2. Radio test 1 2 5. So we got what, 26.24, 26.1 watts. Modulation frequency plus or minus, which is displayed here, 5, just over 4.2, 4.3 kilohertz deviation. I can hear myself coming through the test set speaker, 1 2 3 4 5, and it seems to be stable. It's drawing about 7.64 amps on the power supply that's next to it, so it's reasonable current draw for that kind of RF output power. So that's good, can't see anything wrong with that. I'm just going to give the microphone lead a bit of a wiggle just to see whether we get any broken audio or anything like that, because that obviously would be an issue, particularly around the plug and socket on the radio. And I'm just giving the rest of the cable a bit of a yank just to make sure there's no broken audio or broken PTT. So that was pretty good, and nothing wrong there. Right, so I think we'll have a closer look at the radio now and see what we can find. Okay, well, we just whipped the lid off it to take a look inside, and while I did that, powered it back up, we've got this on the display, corruption. So that was just me powering it up and moving it about, now if I turn the knob, it can sort of clear it, and then it comes back. You can see there the backlight on the display was flickering on and off here. It's gone off altogether now, and then display is gone. That sound plays when you press that M button anyway, so it's not a fault with the radio, that. But there, tap it again, comes back, backlight comes back. Each time you tap it, it does something different. So we'll lost the backlight, then the backlight comes back and the display is corrupt. So yeah, it does seem a bit strange. Sort of doing it more often now that the lid's off, so might just be dodgy connections, you know. The other, they all work, the buttons still, so nothing wrong with them. So yeah, bizarre. So just seeing if I can get it to come back and play ball again, but you've only to touch it a little bit there, as you can see, and the backlight comes on and off as you put in force on the display. So bit of an odd one. Just disconnect it from the power supply. Yeah, one of the common failures on this particular type of radio transceiver, they do a VHF version of this as well as a UHF version, but basically, I've dropped my screwdriver on the floor again. I'll just try and pick it up in a minute, but basically the internals of the radio do suffer with one or two issues. Obviously, the first issue and foremost is this connector that basically links the radio transceiver body to the head. The other issue as well, which happens a lot, is the RF power amplifier that's behind the screening can. It's a brick. Now these amplifiers are hybrid RF power amplifier modules. They typically take about 50 to 100 milliwatts drive to get anywhere upwards, depending on what rating the module is, up to about 40-50 watts. This particular module is rated to about 25 watts, 30 watts, so you know, but depending on who manufactures them, there are quite a few manufacturers of these hybrid modules. There's Mitsubishi, Motorola, NEC, Toshiba, just to name a few, and they all manufacture these hybrid RF power amplifier bricks. Now, one of the issues on these radios, as well as the VHF model that they do, is that the aluminium heatsink cast on the back isn't machined straight, and apparently when they overtaut these screws to screw it down, it cracks the glass substrate that's in the module, which has got the RF semiconductors and filtering on there, so it breaks the RF connection, and thus it fails. And that's a combination of two things really. One, the heatsink mounting plate on the back is slightly out of line. It's not as flat as it should be for the back plate of the power amplifier module, so it gets warped, and also the constant heating and cooling down cycles that the radio goes through when we're transmitting and receiving, so it puts added stress on the internal glass substrates which are in it. It's like a ceramic white tile with all the semiconductors bonded to it, and it's very like glass really, so it just cracks. And it's a sort of thing actually that the CMS radio test set, the ROHDE SCHWARZ radio test set, suffer with on the RF load resistor, which is manufactured out of the same substrate. So it's interesting how, you know, these problems persist with that material, whether it's used in a test instrument or in a radio. The other thing about it is that if I have a look inside, a bit of a closer look, we've obviously got the RF drive circuits down here that provide the low power drive, like on this hybrid module there, to drive the amplifier. But we've got the transmit receive VCO, we've got the alignment holes there for the transmitter and receiver voltage controlled oscillator synthesizer. We've got an antenna switch up here with comprising of some pin diodes. We can see pin diode there, that red beaded device, and we have other pin diodes located elsewhere. We have a transmit receive switch. So incoming RF from the receiver gets directed this way and then goes through these helical resonators, which are bandpass filters on the RF front end, to try and narrow down the radio spectrum to just the narrowband UHF allocation we're using, between 430 to 440 megahertz. It gets mixed with the first local oscillator from the VCO, basically voltage controlled oscillator, mixes with the incoming signal in the mixer. Then it gets converted to what is the first IF, which I'm not sure if it's 21.4 or 41.4, whatever these crystals here are rated at. So it gets down converted into a first IF frequency of a much lower frequency, gets passed through these filters to narrow it off again, because obviously we've got all the images of the other RF carriers that are near the frequency we're trying to select, so this gives this selectivity. And then it gets mixed a second time with a second local oscillator, which is a fixed frequency, probably down to 455 kilohertz or thereabouts, and that's the second local oscillator crystal, which basically is a fixed frequency oscillator. It's adjusted by that blue trimmer there, or it could be the reference oscillator. Ah yeah, I think that's what it is without looking at a service manual, that's it. I think that's the local oscillator crystal, because it's taller, this one. That's the second local oscillator crystal, which is at a fixed frequency, and that mixes with the first IF to then produce a second IF, which is then mixed and passed through this black 455 kilohertz filter before it goes off for discrimination, demodulation. This crystal here, looking at it, it's got a capacitor trimmer cap, and that is the reference oscillator for the synthesizer for transmit receive. So we would be able to adjust that to alter the error. If we remember earlier, we're looking on the test set at the frequency error, how off frequency it was when we transmit, using the reference frequency on the test set of 430 megahertz dead. The test set being high stability calibrated instrument then can tell if this is off frequency. Obviously if this is higher or lower in frequency, then we can adjust that capacitor there then to bring the transmitter onto frequency, and which ultimately affects the receiver as well and make sure that's on the same frequency. Down here we've got voltage regulator IC, audio power amplifier as well for the loudspeaker, and that's what these capacitors are for down there. I'm just looking at this capacitor here because it looks a bit wonky. Looks like it's tilting over, but it's not tilting over because it's blown or packed in. It's just the way they've mounted it, because it's held in with elastic down at the bottom. But I will look at that in more closer detail as we go on. It looks like we've got some option sockets here at the front where we can plug in optional devices such as other functions. It looked for a moment that will plug in there, but these are for other options and modules that you can fit in there for different things, likewise that can connect there as well. And we've got this here. I don't know what that's there for, unless it's to hang it up on a coat hanger or something, but I don't know why that's sticking through there. It seems a bit strange. I'll have to look at that when we get the front off. So looking at it, I'll just take the screws off the bottom, I think. See whether we can look underneath at the bottom next, and see what. Be careful not to damage the speaker, of course. Just remove this these two screws. So they're a good radio, you know, they certainly work well. Got a proper RFPA in them, really. Well, the next best thing to a bipolar device is mounted on a PCB like the good old days, because what came after this was the rubbish that we see today, where they use FETs that are bonded down to the PCB, and then the PCB sandwiched up against a heatsink, with some heat gel or whatever, and these pads, and they just desolder themselves on these QYT radios and this other Chinese rubbish that's coming out these days. It just unsolders itself. Well, on long transmissions it's okay. A lot of these radios, you see, now we're only designed for short transmissions, whereas these radios were designed for long transmissions. That's why I've got such a big heatsink on them, and also you know, with RF power amplifier modules like that in there as well. So, but yeah, so we've got more of the receiver transmitter circuitry underneath, SMD capability there for the transmit receive side of things. Got some ground strips here to connect to the casing to give a good RF grounding. Looks like we've got some little clips, that's all, that'll just hold the front on with the look of it. So if I should technically be able to lever those catches up hopefully, and then release the cabinet front. So I'll just disconnect the microphone and see if I can get a flat blade screwdriver and lift those. Okay, so you just have to pull all the knobs off the front, and then we've got these little catchers here which then lift up to allow that case front to come off. Probably do it with just your fingernails actually, just underneath. That'll get it going anyway. And obviously the catches on the top go back on when the catches on the bottom are undone, and vice versa. So I might have to go back and forth a few times, and then the case should come off then. So that's the inside of the case front. And interestingly enough, we've got a screw there, so I'm not sure if that's part of it. It may well be actually. That looks like it. But we've got the what looks down here anyway to be a connector down there, which goes onto the case front. So I'm not sure if they're soldered there or whether there's another PCB with another plug at the front. But what I'm going to do is I'm going to take these, because we've unplugged the speaker now, I'm going to take these little screws out, and that's if this screwdriver's the right size, which I don't think it is. I think I'm going to need to get a much smaller screwdriver. Let's have a look at this one. Yes, that'll do it. Right, I'll just remove that one. And then hopefully we'll be able to get access to the front. I don't know why that's come out. Let's see whether we can get into it. And then turn it round onto the other side. Right. Disconnect this lead and this end type as well, because this is getting in the way. I was going to leave it connected, but it's just hindering things, so we'll just remove those. Good practice. Okay, so we've got that screw out, that screw out, that screw out. There's just one more on the top there to get to. Look of it. Right, let's just have a look at this, see what happens. Does that come off? Is there any other way to get this off? That will be. Not sure if it's meant to come off at this stage, although I've undone them. It might be that it's not meant to come off. So just have to look at it a bit further. Back soon. It turns out you have to remove these. One goes on the mic socket, these nuts, and the other nut goes on the volume control potentiometer, so it holds this plastic and all the front on. That's how it's connected together. So once you've undone those, then the front should just come away, providing you're careful with it. And there's a bit of plastic there, which looks like it's for these 3 indicators, so you might just have to be aware of that, you've got these plastic straw things which go through for the LED indicators, a few of those. So we'll just put those to one side for a second. So this is what you've got. I think they're for the buttons actually. Yeah, they're the buttons, I think. Yeah, they're just plungers for the buttons. That bit I think goes onto the switch beneath, presses these in, and this is the top bit, so they illuminate. So we can move those to one side, and yeah, because we've got a switch there, LED there, so that's those, and then in between there's a little black switch there, look, where my fingernail is, and that's what that there makes contact with, this other straw thing that's down there. As you can see, let's remove that metal back, put that to one side, that metal frame, just keep my finger on that to stop it from dropping out. You've got a little socket just here, and likewise you've got that same plug and socket arrangement on this board here at the front. So that's just pinged off. Luckily I found it. That goes on the on-off switch, so we'll just put that to one side. So it does look to me like that processor might have been reworked before around here. Seems to be rather a lot of flux residue. I'll just zoom in so you can see that a bit clearer. You can clearly see there's a fair bit of flux residue there, so I don't know what that's about. Just seems a bit strange. Definitely some rework been going on there, I think, possibly. We've got a connector here that appears to be soldered through to the motherboard, just on here, these connections here. So yeah, definitely been some rework going on around there, definitely. I'd say there's a load of flux residue. So interesting. I'll look a bit further under the microscope now, I think, and see whether I can see any dry joints on this socket or this plug. So I'll look at that first. Right, there's another socket as well on this which holds this board onto the transceiver. So there's 2 screws. There's one there which I've just removed. The other is where this transistor is. That actually bolts through the transistor as well. I've just removed that a second, and then that I can remove that. It seems to be captive. But this board now should lift up and come away from this this socket. Might just have to give that screw just a few more turns. That's it. Just a bit sticky, that's all. Not wanting to come off. Right, so put that to one side. So we've got the 3-volt battery there for the memory, radio memory, and then we've two 2 sockets, one there, and likewise the same on the radio itself. So yeah, so obviously on the radio itself we've got these 2 sockets here. So I'll just look at them now under the magnifier just to see if I can spot anything obvious, and then we can try and get that on film. Okay, so if we start to have a look at the board, straight away I can see an issue here round this. That's definitely got a crack there. You can see that. I can push it in and out. That's not going to be causing the problem if I put some pressure on it there, look, and then, so that's not good. That's starting to go, but if I just move it round very carefully, definitely had a lot of resolder work done on this prior. These through holes there, like that one that you can probably just make out, some of these do look dry and they might be worth you know, resoldering, but these through holes not particularly great. But there's another one just up there, look, just there. But just trying to hold the camera steady as I can as we go around the board. Again, some of these through holes look a bit dark, like that one near that transistor. They don't look too bad, although they probably could do with some resoldering. Definitely been some resoldering done there on that surface mount capacitor. That's the lead for the battery. You can see all that flux residue, it's not being cleaned off. Again, these through-hole joints, these look to me like that one there in the middle. You've got a cluster of, well, you've got 3 there on the left and then another 3 on the right. So that cluster of 6, the ones with the darker holes and that one in the middle on the right, to me look like it could definitely do resoldering. These don't look too bad, but they're worth resoldering them. This is the socket for one of the options, I think. Is that one? That's the battery. Again, there's tape holding it down. And these, I mean, that looks particularly bad, does that bit of soldering there, but it's not fantastic. They're the option sockets. Again, the through-hole joint there on the bottom left looks suspect. Not too bad round these surface mount resistors. Again, a lot of flux residue being present. And been some resoldering there, obviously, quite a bit. Bridging component leads together and things like that. Not too bad. That cluster of 6 leads there. Major resoldering done there. Now these are the, that's a connector that goes to this wiring loom, which doesn't go anywhere, so we don't need to bother about that. Now if I turn the board over so we can look at these sockets that go to the radio, that's these. So just looking at them, not too bad. I mean, there's one or two that could definitely do resoldering. That one there on the top left with that hole in it, and it is a hole because I've looked at it further under the microscope and it's definitely a hole. That could definitely do resoldering. Again, these through holes here, they could definitely do with a bit of a resolder. And this is the other socket which connects through onto the radio. Again, not too bad to be honest with you, just the odd one or two that looking a bit suspect, but not too bad. And then these are the processor leads, so if I can get the light a bit better, might be able to get in a bit closer there. Definitely been some rework done on those. Definitely been somebody resoldered that chip there, this IC. That's not too bad, that top row. This looks pretty ropey. That looks like as if there might be something, unless it's my eyes. Yeah, perhaps they definitely need a resolder, because the see if I can get more light on that from down there. Not too bad, but I think, yeah, not exactly being aligned right, has it, at manufacture? Or if somebody's replaced that chip at some point, things are a bit bad. Okay, so if I flip the board over and we have a look at this socket, which is for the LCD display, this is where the LCD display connects to, and again, not too bad. That could definitely do with, that's a resolder. That's definitely been resoldered on that side. Well, somebody's put flux around it anyway. So, yeah, does look a bit strange. Just then on the board, the LCD board itself, this is the LCD board. That connector. Yeah, very strange. Not too bad. Obviously I'll reflow this socket there, but this one's particularly bad, all this PCB being reflowed terrible. There's been some bridging going on there. Look at this wire or something there, somebody's bridged that out. Don't know what that's about. Just there, some bodging being going on there. Who knows? Yeah. So it's been very active in soldering on this one, haven't they? Back soon. Okay, so we've resoldered the connectors on the radio side as well as on this PCB, these two connectors here. If you notice earlier, and we'll look at it under the microscope in a second, this board was full of flux residue, especially around the processor and the connectors, and it was the same on the radio transceiver body as well. All this was caked up in horrible solder flux. We did have a lot of dry joints as well, you know, the solder was terrible, so I've basically used the paste desoldering station to suck all the solder away on the legs of both the plug and socket, and then renewed that solder with fresh solder, and then we've cleaned the board up with isopropanol alcohol. What I've also done is resoldered the chassis connections for these potentiometers and this binary coded decimal switch as well, because it was breaking away, if you remember, from these islands. Then what I've done, I've used this Super Servisol 10 contact switch cleaner lubricant, made in the UK like all good things, and this is a really useful switch cleaner lubricant, and I sprayed that into that little gap down there for the BCD switch to clean that. And then likewise you'll notice there's two rivets diagonally, and then there's two holes on these, on both of these potentiometers, and what that does when you spray into those holes, the ones that don't have a rivet in them, then it goes straight into the potentiometer inside, sort of in within the slider for the variable resistor. So they're nice and clean. They were quite sticky, like as if they were gooed up, and quite difficult to turn. Now they're very free and easy to turn. And then of course we've resoldered all of these as well and cleaned all the flux residue off around the processor and everything. And there's quite a lot of rubbish on the board. This is a rag that I used to clean it, and as you can see, hell of a lot of flux residue came off to deal with that, so it looked pretty horrible. Anyway, we'll have a look at the soldering work that I've done under the microscope. As well as that, I've resoldered this socket as well. This goes through to the LCD board, so let's have a look now under the microscope. Okay, so this is that really bad connector that I was showing earlier, and as you can see, that's all quite nice and clean now. When we zoom in, you know, we can see it's all very good standard, and that's what we want, nice and clean. And then likewise around the socket there as well, and then here too, all nice and clean, nice shiny solder. So that's the sort of thing that we're looking for. And then the processor is all nice and clean now. Wasn't before, it was shockingly bad, you know. So hopefully, fingers crossed, when it all goes back together, it will be working. So onwards and upwards. Have a look at the transceiver board and just get that under the microscope, see what that's doing. So again, quite nice little job is that. Easy to see the solder quality. And then this is the other socket in a moment there, that's the other socket. So it's important to suck the old solder off and suck that away, and then it's easy then to solder some new on, and all nice and clean, which is what we want. Okay, so we put it all back together now, and now comes the moment of truth. Does it turn on and work? So let's see. Yeah, it appears to, and don't appear to be going faulty or anything, so that's good. I'll test it on 435 megahertz then, or 5 megahertz dead. We'll check the receiver and the transmitter, maybe do some alignments. So right, I'll put the SIGGEN on, as you can hear there from the loudspeaker. It's definitely doing something. It's quite good sensitivity at 0.196 microvolt. So we could try and tune that for better, but I don't think we're going to get any better. But we can certainly have a go. On transmit, if I put in a set RF frequency 435 megahertz, entered it in wrong, 435 megahertz. Right, now if I key up on the transceiver, let's just see how far off frequency it is. And no, it's only about a few hertz off frequency really. It's nothing to shout home about. It's quite good. It's doing 27 watts. Radio test 1, 2, 3, 4, 5. Modulation's good, 5, which we're looking at there. 5, 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. So that's okay on high power, on transmit. Now, if we wanted to do alignments on the receiver, we can do that quite easily, and we can just move this light so it gives us a little better. Let's see if we can get that. So, if we go back to receiver test a moment, obviously we can hear the receiver. Now, we've got some helical resonators just down here, because what we've got, if we have a look deep inside this radio, we've got right down here, and I can find something to point at it. We've got a pin diode there, which is a transmit pin diode, and then that's a receive pin diode there. It looks like we've got some trimmer capacitors, helical resonators here, so we can try adjusting those, see whether we can improve its response. This trimmer cap down here, I suspect that blue one adjusts the reference oscillator frequency, so when we're transmitting we can net that so that the transmitter is bang on frequency as well. So let me just get some trimming tools and set up. Okay, let's see if we can improve the signal strength a little bit by getting onto, we'll try that first helical resonator, see whether we can get onto it. It's a flat blade trimming tool I've got here, so if we can get it in the notch. Let's make it worse. Let's make it worse again. So that's better there. Turn the level down a bit more. Try the second one. If we can get on it. It's worse. Better that. And then this one. Try that one. Making it worse. Making it worse then, so just backed it off, found the peak which is there. Try the next one, which is this one here. Obviously making it worse. It'd be a good idea to do this also at the extremities of the frequency band as well, at 430 megahertz dead and 439 megahertz. So the front end's okay. Now if I switch the RF gen off, set the signal, the squelch level, so it's just squelching out. It's 0.1 of a microvolt, or in dBm terms, neg 113 there, neg 118, 9, neg 120, 21, 22, neg 123, neg 124, 5, 6, before it goes out. So it's quite a good receiver. Yeah, very good receiver. So I don't think there's any point in fiddling with anything else. Not sure what the other two caps do down there, the blue and the white one. I suspect they're something to do with the RF path as well. We could always twiddle them, you know, see what happens, but just see if I can get on it. Can't get on it. Nope. That's it. Not making any difference really. That white one does. Out there. Let's go back to that blue one. Oh, there we are, I'm on it now. That makes it worse, obviously. And worse again, so we peak it. It's about there. So if we turn the RF gen off and then set the squelch, RF gen on as well, so that's pretty good. Right, on the transmit side of things then, obviously when I key the transmitter up, we're doing 27 watts, and the frequency, when you look at the frequency here, is 50 hertz off roughly, because if you have a look there where it says set RF, this sliding bar chart there, it says 50 hertz. Now I'm not sure under that, if I go to set RF and then go down arrow, I think on there, oh no, TX test again, I think I can go, there's a down arrow on it, and then it'll show frequency, transduplex, space channel number. Now I wondered if it just might have a different menu system, that's all, where it'll tell me some more information. So basically then we can go onto that blue capacitor that's just down there next to that crystal down here, and we can adjust that then when we can get on it, that is. Because these little trimmers, they're okay for most capacitors, but some capacitors are more difficult to get on than others. Right, I'll keep the transmitter and alright, so that isn't the reference oscillator then. That must be for the receiver. So let's just have a look at going back to the receiver. Ah, it is. Right, let's tune that for maximum output. perfect there. So I'm not sure whether the reference oscillator on these is tuned electronically. It could well be through the settings, and that's what changes the frequency of the reference oscillator. Some radios, a trimmer capacitor tunes them, and other radios they're done through a varactor diode, which is controlled by the microprocessor as a DAC value, so that you can increase or decrease the voltage to the varactor, and it'll tune the oscillator, reference oscillator, one way or the other. So it may possibly be that there are some other potentiometers, but because I don't have a service manual for this radio, I'm not going to adjust them, because I've got a funny feeling that they are for other things which I don't know, and obviously I might cause an issue. There's probably low, medium and high power pots of these probably, and there's a pot at the front there, the yellow one, which is where my thumb is, which I suspect might be for receive audio or transmit mod or something like that, but it's very difficult to tell. So I'll just turn that squelch up, and then obviously, you know, it's working as it should. So I don't think there's any more enhancements that we can do to it to get it to work any better than it currently is. Yeah, it's doing 28 watts. Modulation's fine. Everything seems to be okay on it. So I really can't grumble, to be honest. I think we'll reassemble it now, and then have another look just to make sure everything works. Right, we've got the covers all back on now and everything back in the way it should be. The speaker should be a lot better now, because obviously it's in an enclosure, whereas before it was just out of its box and loose. So we'll just go to RX test a second. I'll set the frequency to 430 megahertz at half gen level, and then it's very good in microvolt terms. It's 0.1. That's pretty good. Now there is a feature on the ROHDE SCHWARZ test set where if you couple the audio output of the radio receiver into the audio input ports on the front here, which will be, you know, the AF in, the AF scope port here, there's a feature where you can do a squelch search, and it'll automatically find the hysteresis point of the squelch. So you'll set the squelch, if it's preset internally within the radio on the front, whatever, you set the squelch up, and then what it'll do then, it'll adjust the RF level until it sees the point where the RF is fully quieted, the audio signal coming out the radio, and then it'll turn the signal RF down until it reaches a threshold where the squelch activates, and then it'll come up with a result on the display. So I'm just going to see if I can get my audio lead to see whether we can do that and show that example. But as you can see there, the sensitivity is pretty good, you know, no problem with that. The receiver's exceptionally good, and if I do if I turn the frequency on here to the top of the band now, and we put in 439.975 megahertz, so we're checking both the bottom and the top of the band. You can see again, nothing wrong there at all, you know, with the sensitivity. So it's pretty good, you know, very good spec that. There's not many receivers can achieve that kind of specification. Normally it's around about 0.3 microvolt with a lot of receivers, whereas this is quite a good receiver. Likewise on TX test as well, on transmit. Forget the microphone that we've got here, and we keep the radio transceiver. We're getting recorded output power at 439.975, 1, 2, 3, 4, 5, at 27 watts, call it 28 watts on high power. And then obviously if I switch the band to 430 megahertz dead, we're getting very similar power again, 26.85 watts. So there's nothing wrong with the transmitter. At top and bottom of the frequency range, it's same, almost identical specification. So I'll just find this audio lead now for this receiver test, and then we'll see whether we can, we can get that hysteresis automatic measurement demonstrated back soon. Okay, so now we're ready to do the Squelch hysteresis measurement. The ROHDE SCHWARZ test sets, the CMS33, has got some built-in extras, which is unlike a secret sub-menu under the RF level control, which we're going to look at in a moment. In order to measure the Squelch opening and closing point automatically on the test set, which it does as part of an ATE program that it runs, you've got to connect an audio lead, which we've got here, into the scope AF input port on the front of the test set, and then the other bit goes into the back of the radio on the 3.5mm jack plug. That's so we can do both SINAD, signal to noise and distortion measurements, distortion measurements, as well as quieting, and then the squelch measurement as well. And we can use it for measuring the audio level as well in terms of AF volts. If we wish to measure the audio output stage of a radio terminated into an 8 ohm load, a resistive load, and then measure the voltage across that load, obviously we can calculate the AF power output then of the AF power amplifier on the radio, because obviously we get faults with radios as well, with the power amplifier for the loudspeaker fails, and it can be either no output, horribly distorted, or very little output at all, depending if it's electrolytic caps that have gone dry, or the silicon chip itself, blown a hole in itself. So we've got the audio connected into the front of a test set. Obviously the radio squelched out at the moment. I'm just going to introduce the signal generator, and now of course we're capturing the 1 kilohertz tone from the receiver on the oscilloscope there, the sinusoidal waveform at 1 kilohertz. We've introduced a low pass filter, which is got a cut-off frequency at the upper limit of 3.4 kilohertz. Obviously we don't want to be hearing all noise and hiss and things that are in the higher frequency component of the audio. We just want to be concentrating on that 1 kilohertz tone. So in this measurement we can actually do SINAD measurements, which is displayed here. It's currently 22 dB, and from that you can then define the 12 dB point on the receiver. So we can basically reduce the RF level until you get it to the 12 dB point, which is commonly the quotation given in the specifications of the service manual for the radio, and it will say that the receiver's got to be better than, say, neg 120 dBm at 12 dBs. So in this case it would be neg 124.5 dBm for roughly 12 dB SINAD. So that means the receiver's overperforming. It means it's a good receiver. Obviously if you needed a lot of RF level, and you were, say, putting neg 98 dBm in and not getting 12 dB, it was say 6 or 8, 9 dBs, then the receiver would be deaf. That would exhibit a fault on the receiver, or it not being tuned correctly, or an open circuit antenna connection, that kind of thing. So these are aids to help you with fault finding. Likewise for distortion as well. When we're aligning receivers, as we were doing earlier, you can align the receiver for minimal distortion, so the sinusoidal waveform is as clean as can be coming from the receiver. That's particularly important when you're aligning things like Foster-Seeley discriminators, which are FM discriminators. There's a discriminator coil that you can tune, and that waveform will become heavily distorted, or it'll become wonderfully clean depending on how you set it. And it'll be obviously have an input on the distortion measurement as well. So these are all parts of the alignments that you do as part of the radio receiver setup, but we're only dealing with 1% distortion there, which is very good. So there's no need to do any adjustments. The SINAD's better than expected. Right, so onto the Squelch trigger tests, which this radio test set can do on its own. So we select RF level, the down arrow, and then amongst various measurements that we've got the Squelch checks. So what that's going to do now is when I set the Squelch to say whatever level I want it, it's going to tell me what level in microvolts. or dBm, or whichever level we've got it set to currently, which we've got it in dBm, what that level would be for the squelch to both open and for it to close. So if I just press this button now, and now it's going to go off. As you can see, it's adjusting the RF level automatically without me having to do anything. And it's going to do a couple of tests now just to see where the squelch opens and where it closes. And then it'll display that result here. So there we go. So it's given me a figure there of neg 123.2 dBm for the squelch to be switched off or squelched off. And then it's got a 0.8 dB hysteresis. So some receivers have incredibly long squelch tails on them. Some have very short squelch tails, depending on what kind of receiver it is and how good it is, and the manufacturer and what kind of components have used. So if we then increase the squelch level, for example, and say to midway, and then repeat that test, then that level should change, because ultimately the squelch is now tighter, and thus it needs more RF level in order to allow the squelch to open. So that's what we're looking at now, and in a moment it'll reveal its result. So now we're at neg 118.4 dBm for the squelch to be switched off with a 2 dB hysteresis. So as you can see there, the level changes depending on whether we set the squelch. Now some people might think, well, why do we do that test? Well, it's for a very good reason, because sometimes squelch circuits in radios fail as well. So the receiver might be working perfectly well, the transmitter might be, everything else about the radio could be functioning correctly, but then the squelch circuit might not be performing properly. And I've had plenty of radios over the years where the Schmitt triggers and things like that that are used for the squelch mute to the AF amplifier, it goes faulty, dry electrolytic capacitors, failed diodes, things like that. There's all sorts of reasons, but that's what that test can do. You see, it can show that the squelch control, no matter what position it's set at, we can check it to see whether, you know, obviously the squelch is working properly. So I've just turned the squelch almost fully clockwise now, and again it's repeating that test again. Obviously the RF level should change from before to a much tighter, higher RF level than previous. So we've got to exert more RF into it in order for the receiver to open. So as you can see there, it's now neg 116.5 dBm for the squelch to go off. So it's quite a tight squelch, and a 2.8 dB hysteresis. So that's basically just verifying that the squelch control is fully functional. So that's that, I think. I don't think there's anything else really. I think we've more or less covered it. I mean, obviously the radio test set in this case is a fully featured ROHDE SCHWARZ radio test set. It does so much with these sort of secret menus and various other things. If you were doing the alignment of the front end, you can take out an RS signal or from the front end and then feed that back in on a second input port. So we're injecting out here, and it'll be waiting for it to be received on that port, and you can do what's called a bandwidth measurement as well. And then there's a quieting test as well. There's all sorts of tests that this test set can do. So again, fully featured radio test set. Now the radio obviously seems to be working. I can't get it to go off, or I've tapped it and banged it and had it switched on for many hours now, and it seems to be okay. So I can put that down to obviously the faulty plugs and sockets on the LCD board, the control board at the front, and then the main PCB. So like 3 lots of plugs and connectors on each board to resolder, and remove the old solder first before applying new, obviously. Obviously there aren't any other faults on the radio that we can see. Everything's fine. We've checked both for transmitter, RF power, the AF modulation from the transmitter, the frequency modulation FM. We've also checked the receiver sensitivity, the SINAD, distortion. We've done a squelch hysteresis check. All the controls are fully functional after doing all the resoldering work that we've done, and we've sprayed some Service All contact cleaner inside the controls to clean away the years of dirt build-up that's occurred in there. So everything's fine now. The radio's ready and working again. So anyway, I hope you've enjoyed the video. It's been quite an interesting repair. Not too in-depth, not too involved like some of the repairs that we've done on the channel, but it's nice to show radio transceiver being repaired as opposed to radio test sets being repaired. A bit of variety. And if you like the video, please subscribe because it helps the channel. And we'll see you in the next one. Thank you very much for watching. Stay safe and put your comments below if you wish. Bye for now.